Our next speaker, Ken, has come all the way from sunny California, I believe, right? It's
Yes.
sunny. It's sunny today here in
Yeah,
Madison.
my wife tells me it's very hot there. So
Okay.
global warming, you know.
Yeah, sorry, I tried to.
Sorry.
Okay, thank you. Well, I thank the organizers for including me on this program. This is the first time I've attended. I started using HTCondor about 20 years ago. Then I was diverted and now I'm back. So I want to point out that, yes, in the program I'm listed as being associated with Stanford University. I'm really a senior fellow at the Hoover Institution. I'm not on the faculty there. And that's an important distinction, or at least the faculty at Stanford really think so. Now, I'm an economist. Now, before you lose all respect, I want to first say that my 9 years at the University of Wisconsin began with a joint degree in mathematics and economics, and then went to grad school in math, hoping to ultimately be a math professor. But then in the late 70s, the job market in math was just abysmal, and I wanted to do academics, so I switched over to economics, where I have been using my math skills. Now, I should say my math abilities. Actually, none of the math I took as a math student helped, because I specialized in mathematical logic. Now I'm doing nonlinear functional analysis, but I'm not afraid to go into the math library. And that's what separates me from most economists. Now, economics is, okay, some people say it's a science, some people say it isn't. Well, it certainly isn't as practiced. Now, I argue that economists should proceed like engineers. By the way, economists are in the business of designing institutions, designing things, designing a monetary system, a tax system. Now, like with engineering systems, we understand little pieces of an economic system, but then things get messy when you combine them. And that's the same problem that a designer of an airplane faces. You may understand how the Bernoulli flows over the wings and various things, but when you put it together, you don't know what's going to happen, so you do computer modeling. And so engineers do that. They used to build planes and then see how long they could stay in the air, but now they build computer models, and then they look at alternative designs and choose ones that are efficient. Also, the other thing about engineers is they're very careful in terms of looking at failure modes. It's not just enough that a plane usually lands safely. It's considered very bad if it ever crashes because of some design flaw. Now, economists have only a fuzzy understanding of the individuals. We kind of believe we understand how they act as a mass group. Isaac Asimov fans will understand my reference to Harry Seldon and psychohistory laws. That's kind of what economics is. But they focus on tractable models. Oftentimes you see people bragging about, I have a tractable model this, a tractable model that. I prefer good models, useful models. As a university professor in statistics here said many years ago, all models are wrong, some are useful. And he's half right about economics models. Now, also the other thing that's disappointing is that they brag about how on average they get things right. Yeah, like on average, except for the fall of 2008. They really don't have any. It's like they say, well, you know, you can't predict everything. Sometimes things go wrong. Now, I've been at Hoover for 37 years. I've been trying to teach computational methods to economists. I haven't been very successful. I'll point out two of my failures. This guy is now the president of the Federal Reserve Bank in New York City, the number 3 spot in the Federal Reserve. Let me give you an example of how macroeconomists affiliated with the Federal Reserve excused the poor performance around the Great Recession. The excuse given at a congressional hearing in 2010, a macroeconomist said there are 2 reasons. One was weakness of computational power of laptops. I reminded him afterwards that his university at Minnesota has a supercomputer. He had forgotten about that. He also then went on to mention the limits of the human mind. The limits of the human mind. What an excuse. I asked him when I saw him, I said, now whose minds were you thinking of? You should have seen the look on his face when he realized what he had put his foot in there. But that's the excuses you get, you see. Now, on the other hand, what do you expect? Top economists in academics departments at state universities get $600,000 a year in salary. I know that's obscene. I don't disagree with that. The Fed system average salary is $200,000. So, gee, do you really expect them to do a good job? By the way, even you could say, well, you don't expect any one of them to do a good job, but when you have 1,000 of them, maybe no, it doesn't work out that way. And they have 1,000 PhDs and they're paying about $200 million in salaries for these guys. So remember that whenever you hear about how macroeconomists making excuses. Williams in particular, I gave him crap about some program he wrote some years ago. And then later they made a big deal about how they rewrote the program in Python. Now, my attitude is, if you have a pig, you put lipstick on the pig, what do you get? A pig. And that was the case with this economic model that Williams was pushing. Now, there's a local connection here. Some of you Madison people might recognize this guy. He was also a graduate student at Stanford when I arrived there. I told him many times he could do much better research if he started using good computational methods. And then he decided to go into university administration. He's now wearing green. Still in the Big Ten, but wearing green. Now, so Stanford is not interested in supporting what I need. Also, several years ago, I challenged the provost at that time about how some universities provide substantial computational resources for free. The provost said that won't happen here. This is when I really started to understand just how unusual and valuable the Wisconsin idea is, and how HTCondor and Morone-Livni is really a great example of that. So 20 years ago, I needed to do some computing, contact HTCondor, and Morone gave me unlimited access at 0 priority. And that's what we needed. Now, to the computer science stuff. How can economics use HTCondor and computers? It turns out that a lot of economics problems can be broken into lots of little problems, and then on which you can apply a wavefront abstraction. This is wavefront was something that I did in this paper with Doug Thane. And so here's what wavefront looks like. You have like a boundary condition, and then from there you can go out and solve all these other jobs. So this is an example of wavefront. And so even though you may have an enormous problem, a lot of problems in economics can be solved in this fashion and using, well, Dagman or master worker. And so what happens is you start doing a few computations and the numbers. So you start down here where you do a few jobs, and then as you proceed, you end up with lots of jobs that can be done asynchronously. And this is just a two-dimensional picture. You can imagine that this gets even better in higher dimensions. Now, by the way, this is also ideal for HTCondor through high throughput, because when you're down here, you don't need many processors, and then as you proceed, you need lots here, and then as you finish up, your needs drop. So that's exactly what is great in high throughput computing like HTCondor, but not so great if you got a supercomputer. Here's an example of an economics problem, the prototypical problem, which, by the way, the technology was described in a paper that I wrote with Greg Thing. I got to give equal billing to both things. And so we did what's called dynamic programming problems using master worker. And now this is an example that coming up with economics examples that non-economists are interested in is hard, but I've always found that talking about portfolio management is something everybody understands. So suppose you have some objective of some valuation of wealth in the future. You have some idea about how much you value wealth in the future. And then given that, you make investment decisions. So if you know what your investment plans are between now and when you retire, well, then you know what can compute the optimal plan today. And then you go back in time. So this is an example of how you can solve it in a master worker fashion in particular. So this is a canonical problem. Think about portfolio optimization, and that's what we're doing. Now, Young Yang used this in his PhD thesis. This is 20 years ago, and used up to 200 CPUs at Condor. Everybody's surprised when I say he had nothing like that to use at Stanford, so I often point out that the cobbler's children often have no shoes. So much for Stanford economics. Now, after that, then Young Yang and I decided that he came along to get into the business of climate modeling and economic policy. The state of the art in 2010 was, the US government came out with a report about what the cost of carbon was. And they had some analysis in there. Now, by the way, economics, you think of climate science, you think of all these big supercomputer models that the climate scientists use. Yes, that's fine. The economists take enormously simplified versions of those, dramatically simplified versions of those, and then add some economics. And that's what this guy Nordhaus did. And the government used his code. I and my guys looked at the code, and we saw that there's something wrong in the code. And in fact, he had assumed, because he's a macroeconomist, he didn't understand how to do numerical optimal control. So he did a screwy finite difference system that meant that CO2 emitted 10 years from now would start warming the Earth today. And that meant that all the government's numbers were about 25% higher than it should be. Time traveling CO2. Now you can imagine they don't like me in Washington. Now, by the way, after that, after this and after we published our paper about how he was off by so much, he got a Nobel Prize in economics. Now, by the way, I always emphasize to people the Nobel Prize Has nothing to do with Nobel. It's not a real Nobel Prize. So here's the problem, is that there's a lot of uncertainty in the economics. All these models assume that you can perfectly predict the future economy, that you can perfectly predict climate, and also assumes that we know exactly what all the laws of motion are. That's not true. That's crazy. We wanted to look at more complex models, and we went to the Blue Water supercomputer. Now, the key thing here is that in physics, you're used to solving initial value problems. You have an initial condition, and then it plays out over time. Economics is not an initial value problem, because the decisions that people make today depend on what they expect is going to happen and what they expect to do in the future. Mathematically, when you write this down, it's a 2-point boundary value problem. You have like your initial wealth today, but then you have some terminal condition. For example, when you die, society is not going to let you leave in debt. So that's a terminal restriction on your asset management. So that's what that makes economics so much more difficult than physics in many ways. So now what we did is we did add here's a little diagram of our model. We have the economy, there's emissions. Some of the emissions is mitigated. Then here's a 5-box model of the climate, 3 layers of the ocean, 2 layers of atmosphere. And then that may damage the economy, but through heat. But then now what we added to this is we had stochastic elements of climate, such as tipping points, glacier melting at unpredictable times. And then also we had stochastic growth. Now, economic growth is very uncertain. For example, when Mao died, nobody would have predicted what happened to the Chinese economy in the following 40 years. That was completely unthinkable, but it happened. And now you look at the demographics of Africa, you've got a population explosion there. You can't predict the economy 20 years, 30 years, 40 years, 50 years out. So that's why it's important to include that. Now in the slides, I have some math. When we went to Blue Waters, we needed 84,000 cores run for eight hours to solve one example. Now, what was the payoff of this? Well, you see, this is an economic model with uncertainty. So the economy is getting kicked around by various stochastic factors. So what we can do is we can solve. By the way, no money. It's a PDE. It was a 12-dimensional Hamilton-Jacobi-Bellman partial differential equation, but it's a heat-like equation. So nonlinearities aren't going to screw us up. No shockwave stuff. So then we solved for the laws of motion, and then we simulated what would happen. And so the median case would have, by 2100, an increase of 3.5 degrees Fahrenheit temperature-wise, which matched what the basic deterministic models have. But what we added is we said, hey, there's a 25% chance that you're going to get above here, and a 10% chance or a 5% chance that you might get more than 6-degree warming. That's what is ignored, is that is the risk of really bad events. And so think about this as, you buy fire insurance on your house. You don't expect there to be a fire. You still buy fire insurance in case there isn't. And that's the approach that should be made. Now, I have some comments. By the way, economists didn't like it. One reaction was, Ken, it's nice to write papers for smart people, but that's not desired. Then you can read more about it if you do a Google search for Heckman-Judd War. Oh, by the way, I only go to war with people with Nobel Prizes. So I tell this to people because they're afraid that I might criticize their work. Now, so what can we do in economics? Remember back in the wavefront example, the kinds of problems that we can, you see, we take economics as big problems, but we can break it down to little pieces. And in the case of dynamic programming, the little pieces were constrained optimization problems. And so at each node, we did a constrained optimization problem. Or one of my students did, at each node, you solve the system of polynomials. You may have an enormous system of polynomials with enormous degree, but it decomposes into a smaller system. Could be nonlinear equations. And in that case, I would use PATH, which was developed here. So my goal here is to make this accessible to economists. This is a challenge. As Greg will remind you, one time he gave a seminar, a presentation at a workshop I organized, and he first told the students, okay, now log into SSH. Well, I knew that was a problem, but somebody had to act like the idiot. So I said, Greg, what's SSH? And he's backed, oh, okay. So he backed up and said, see, that's what you're dealing with. But I think that, you know, this could overcome with some help, perhaps from the lady that yesterday was talking about documentation and that, because reaching the economics audience is going to, you can't use the documentation that's on CHTC. That's written for computer scientists. You've got to do a lot more hand holding. But I can tell you how to hold the hands. And by the way, I'm at Stanford. They do take out my trash. They do process my paycheck and health insurance, but they don't give me any research support. So you're helping. I'm going to ask people to help me. You're not helping Stanford. So there's a variety of projects here I list. Economics needs to use modern computational methods. There's a lot of low-hanging fruit. And HTCondor and OSG can be extremely helpful. And I thank Marone for all the help he has given me. And I hope that this can continue now with OSG, and I can tell everybody about this. It's great. Thanks.
So thank you, Judd, both for your work and for the kind words. So what can we do on our end?
On your, what I
to, yeah, I mean, access
yeah.
is a given. Is there anything
else? I am finally able to put together some people, and I finally have some financing.
Okay, that
to get good people together.
As you know, in economics, the wallet is an important part of the model.
Yeah. Oh boy, I know that.
So
I know that very well. So I will be asking, you know, not only access, but like I said, reaching economics community is going to require documentation and some hand holding. And that's what you guys can help me with. And also then my guys, I have some pretty smart guys, but you know, we're not professional computer scientists.
Yeah,
so.
yeah, but you shouldn't, because we need economists now. We have we need a step-by-step guidance on how we can do better.
I will give that, and I thank you for your help.
That was a fantastic talk, and don't disparage the fact that Stanford takes out your garbage, because we have great research computing support, but in our new building, nobody takes out the garbage. So
I will have to compliment the staff. I have run many conferences over the years and workshops, and I often have to tell them to put the name on both sides. But that was done here. Thank you.
Thank you so much.